Well, ladies and gentlemen, today I want to present our work on the UNLP 2025 shared task on detecting social media and manipulation. We have hosted and analyzed results of these tasks by Kyslyi, Nataliia, Romanyshyn, and Volodymyr Sydorskyi. To start with, I would like to outline the motivation for such a topic for the shared task. So we have chosen detection of social media manipulation because of three main reasons. First of all, rising influence of disinformation on platforms like Telegram, especially in Ukraine. Because of this, there is an increased need of automated tools in order to support media literacy and counter propaganda and manipulation. Finally, Ukrainian still is a low-resource language, so it lacks such dedicated models and tools that are abundant for other languages. To start with, I would like to elaborate a bit on the data that was specially collected for this task. So the data consists of more than 9,500 Telegram posts from Ukrainian news and political blogs channels on Telegram. It was specially created by texty.org.ua and provided for this shared task. The dataset included both manipulative and non-manipulative posts. Also, the dataset is already published by CC by NC CA 4.0 license and can be used for other research purposes. So in order to elaborate on the labels that were created for this dataset, it was created again by Texty. And the initial labels were taken in the cooperation with Detector Media. After that, there was a discussion with focus groups of Ukrainian journalists, editors, and media analysts in order to resolve hard cases. For example, it can be decision with rhetorical patterns, which should be considered as manipulative. Distinguished manipulations that may be acceptable during the active phase of the war, and also identify the techniques which can be viewed as the most destructive on Ukrainian Telegram. As a result, the dataset was obtained. It included not only Ukrainian posts, but also posts written in Russian, as it's also used in some Ukrainian Telegram channels. And in the table, you can see distribution between Ukrainian and Russian languages and manipulation across them. So we can see that still Ukrainian is more represented in our dataset. Going directly to the shared task consisted of two tracks. The first track was dedicated to technique classification. So the task of this track was to identify the specific manipulation techniques which was employed with a given text. And the second track was dedicated to span identification. It is kind of name entity recognition task when you have a text and you need to identify which tokens or spans are considered as manipulative. It was labeled on the binary level, so there was not particular manipulative technique labeled, but just is the span manipulative or not. Input texts were same across both tracks, but targets were different. Let's start from technique classification track. So it was a multi-label task. It was labeled on a post level. So for each post, there was a binary label for each of 12 manipulation techniques. And you can see the distribution of manipulation techniques present in the table. As we can see that the task is pretty unbalanced, with the majority of posts belong to loaded language, loss of pause belongs to cherry picking and glittering generalities, and only a couple belongs to strawman, bandwagon, and whataboutism. So each post might have several manipulation techniques which participants should predict. The accuracy of the participant systems were evaluated by F1 macro, which contributes to the balanced nature of evaluation um, and evaluate each class equally. The next track was span identification. As was already mentioned, it's kind of name entity recognition type task, which was proposed in a binary format. In order to evaluate system performance, token level F1 metric was used. The important point in the metric formulation was that it's directly token level, not a span level. It was used in order to reduce metric sensitivity to missed punctuation, white spaces, and some small errors, for example, in several characters. On the slide, you can see an example of labeled text, and you can see that commas are not labeled, white spaces are not labeled. So if the participant predict the whole this text as a manipulative one, he or she might get 0 for a span level because commas and white spaces were also predicted, which is false positives. But while we compute it on the token level, each token will be evaluated separately, so the metric will be nearly to 1 for this particular message. The competitions were conducted on Kaggle platform, and in order to evaluate robustly systems, several data splits should be provided. In a classical approach, in order to use Kaggle competitions, hosts have to split their datasets in 3 main parts. First of all is a training set, which will be provided to participants in order to train and validate their models. The second one is a public test set, from which only input will be provided to participants, and they can track the performance of their system by submitting to a Kaggle platform using 5 submissions maximum per day. And finally, there is a private test set which is also exposed to participants only part of the input. And the scores on the private test set is hidden during the whole period of competition and are exposed only at the very end, and are used to make the final decision regarding the best performing system for this particular competition. In such an approach, there is no direct overfitting to some test set. For example, it can be public test set, but there is no direct overfitting to private test set because participants cannot see private metric scores during the whole competition. In order to perform such a data split, we have used multi-label certification algorithm based on manipulation techniques label. Finally, we have splitted all our data set into 5 folds, each fold containing 20% of data. First and second fold was used in training set, third and fourth in the private test set, and the final fold was used in public test set. As we can see by the plots on the right side, the correlation between private and public scores are nearly ideal. It also supported by the Pearson and Spearman correlation coefficients, which we can see on the table, which supports the idea that the data distribution was very, very similar between private and public test sets. Regarding the statistics of participation in shared task, we had 53 entrants in span identification and 65 for technique classification. From these, we have 32 participants for spine identification and 46 for technique classification. These participants gathered in 12 teams for spine identification and 20 teams for technique classification. And overall, we have 216 submissions for spine identification and 386 submissions for technique classification challenges. You can see the results on the screenshot. So we can see that GA team scored best on both challenges and ultimately secured top one position both on private and public leaderboards. Team Molody and Ambitny secured second position on technique classification track and third position on spine identification, and CV is better Siu secured third position in technique classification track and second position on spine identification track. Also regarding the system performance, best system performance reached nearly a 0.5 F1 metric on technique classification, which is pretty good, pretty high score, taking into account the number of classes, and reached 0.64 F1 score on span identification, which is also pretty good result considering noisy labelness of potential noisy labeling of manipulation techniques, which is always where is always subjective part of labeling is present. So let's take a look at some highlights of team's solutions. So Team GA explored several transformer techniques from which we can highlight MD Beta, AYA 101, Llama, Mistral. Finally, they have chosen Gemma 27 billion, and because of their best performance. In order to optimize class balancing, they have used specifically designed threshold adaptation technique via grid search and regularization. Finally, they have improved their system stability by ensembling across of different faults using out-of-fault prediction strategy. Regarding span identification approach, they have tried M-Berta, XLM-Berta, Euro-Berta, MD-Berta, and they have found that MD-Berta most effective among small encoders. They have improved their transformer architecture by by enabling bidirectional attention. By enabling bidirectional attention in order to increase in order to allow the model to see previous context. They have also employed transfer learning techniques in order to pre-train on Ukrainian and Russian use corpora using masked language modeling. They have also used character-level binary labeling instead of by UTEX and also optimize span thresholds via grid search. Final model is also ensemble across of faults. Talking about solution of Team Molody and Bitny, for technique classification, they have also used Gemma 2, but a bit smaller version, adapting it with low-rank adaptation techniques for parameter-efficient fine-tuning. They have used several stages for fine-tuning, first which was a casual language model and a second sequence classification. They have included special prompts which were constructed using class descriptions and similar selected examples. Final classifier combined both LLM outputs and CatBoost-based metadata features. They have also used special techniques in order to optimize threshold selection. Regarding the solution for spine identification challenge, they have explored XLM Roberta. For binary token classification, they have used a multi-target classification head and again employed careful cross-validation in order to optimize thresholds. And the last but not least, CB is better SEO. In order to approach technique classification task, used XLM Roberta Large in a multilingual settings. They have addressed class imbalance using the next techniques like weighted binary cross entropy, label smoothing, and world-level data augmentation. In order to enhance model architecture, they have used Jello-activated preclassifier and multi-sample dropout. In order to build a smoother training strategy, they have employed ADAM-V optimizer recursion scheduling and gradient accumulation with early stopping. They have also used dynamic threshold tuning based on per class F1 score, and they have used a special language-specific preprocessing and heuristic for Ukrainian and Russian languages. Regarding spine identification solutions, they have used XLM Roberta with biotagging for token classification. Regarding their training techniques, they have also employed LoRa for better layer utilization, weighted focal loss to address stroke 11 class imbalance, and early stopping to prevent overfitting. In order to post-process their predictions, they merged adjacent spans using a threshold-based strategy and deployed balanced sampling and token level F1 in order to evaluate their system. Finally, we want to outline limitations of our work and of the challenge that was conducted. First of all is a data scope, which was limited by the Telegram data source and also limited only by Ukrainian language. And this can be enlarged in the future works. Next point is a technique granularity. It's very subjective and hard in order to pick a correct granularity for manipulation technique. Also, the set of manipulation techniques can be extended based on different scientific works. More deeper analysis of this is also left for the future researchers. Finally, data split can be also improved. It can consider grouping by channels, by Telegram channels, for example, in order to exclude a possible link between different data sources, and also implement a time split strategy in order to evaluate how systems and models can perform learned on the previous data and predicting into the future. Regarding the conclusion, we would like to outline main points and contribution of our work. First of all, we have established new benchmarks in a task of manipulation techniques detection for Ukrainian media field. We have introduced a novel new manipulation technique detection dataset. And finally, while conducting a challenge, a number of strong baseline in two task manipulation technique classification and manipulation span detection were gathered. Thank you for your attention, and I am ready to answer on all your questions.